Hello friends, a very good morning to all the students. Am I audible to all the students? Okay, fine. So friends, before starting the session, let me congratulate you all because I have received the BME assignment from all the students of this batch. So it is a very good positive response from all the students in submission of the BME assignments. And also the submission is done on the time. But friends, let me inform you some of the important points which you need to remember for the assignments from the next assignment onwards. I had initially informed you that for presenting the assignments, the presentation is a very important parameter. And dear students, all the questions we are sending to you in the assignments, all these questions are the most important questions, and there are chances that these questions might be asked in your theoretical examination. So in your presentation, in your notebooks, you are presenting your answers perfectly, understanding the concepts perfectly, then same manner can be reflected in your examination as well. I have observed that some of the students has given the answers, written the answers from my particular lectures, the PPTs which I have shown it to you. But dear students, I just instruct you that you need to follow the standard textbooks. But you need to present the answers according to your particular pattern. No need to write down the paragraphs which are given in the textbook. You can present your answers point wise. You can include some new innovative concepts in your answer in order to get more marks. In the first question of the classify of the thermodynamic systems and give two engineering examples, majority of the students had just written the theoretical approach, but only few students has drawn the figures of the open system, closed system, isolated system, and also few students has shown the examples with the figures in order to understand the concept. So friends, now from the next assignment onwards, try to understand that figures will be more effective than writing down the theoretical concepts. If you are presenting the figures perfectly, then examiner will be very convenient to check whether you have understood the concepts or not. So after you have presented the figures perfectly, you can short down the theoretical points. You can just mention some of the basic points in the answer and you can proceed further. And using the figures also give a good presentation to your answers, and it becomes very easy for the examiner to check the answers. And seeing the figures, he can give you the good marks. So try to follow, try to develop some new concepts, some new methods in writing the answers of the assignments. And I'm sure this method will be very useful to you in getting good marks in the examination. I hope my these instructions are clear to all the students. I want your comments in the chat box. I hope my points the students are understanding. Okay, fine. So friends, you are aware that we are discussing the fifth unit, that is the heat engines. And in the last lecture, we have discussed one of the important cycle, that was the Carnot cycle. So dear students, anybody can give me the answer in the chat box. What was the final equation of the efficiency of Carnot cycle? What is the final equation of the efficiency of the Carnot cycle? One minus TL by TH, okay, that is the lower temperature divided by the higher temperature. Okay, so I am getting the perfect answers from majority of the students. Thank you all. That means you are understanding the concepts and also you are preparing the concepts. Okay, fine. So let us proceed further, and in this lecture, we are going to understand the second cycle of the heat engines, that is the Rankine cycle. So these are the main contents I am going to discuss in the current lecture. First, we will be understanding some of the basic concepts related to the Rankine cycle. Then we will understand the different processes taking place in the Rankine cycle. Finally, we will make the derivation for calculating the efficiency of the Rankine cycle. And in the last, I will show you one of the practical application of the Rankine cycle. So let us start with the discussion of the Rankine cycle. Dear friends, in your textbook, after the Carnot cycle, one theory will be given, that will be the Carnot vapor cycle. But Carnot vapor cycle is just for the understanding of the Rankine cycle. No need to focus more on the Carnot vapor cycle, but we need to focus on the Rankine cycle. So in the Carnot vapor cycle, there was one limitation, there was one drawback. The limitation of the Carnot vapor cycle was that it was very difficult to pump the mixture of the liquid and the vapor by means of the pump. And because of this limitation, the efficiency of the Carnot vapor cycle was calculated to be very less. So the Rankine, he studied, analyzed the Carnot vapor cycle, and finally he come up with the solution in order to increase the efficiency. So in simple cases, in simple words, the Rankine cycle is the modification of the Carnot vapor cycle. The difficulty of the Carnot vapor cycle is eliminated in the Rankine cycle by the complete condensation of the vapor in the condenser and then pumping the water to the boiler by means of the feed pump. So in the Rankine cycle, what he did, he just used the condenser where the complete condensation of the mixture of the liquid and vapor was taking place. And when the complete condensation was done successfully, the water was removed from the condenser, it was transferred to the pump, and finally it was transferred to the boiler. So using this implementation, using the simple modification, Rankine observed that the efficiency of the cycle was increased. Proceeding further, the Rankine cycle describes the closed cycle systems using the external heat sources and the two-phase working fluids. Here remember friends, the working fluid is the same, that is common, but during the operation of the cycle, the phase of the working fluid changes. So the change of the working fluid, that is Alternately, it is condensed to liquid form and the vaporized form, that is to the gaseous form, as it is expanded and compressed during the heat cycle. As I am proceeding further with the discussion of the Rankine cycle, the processes of the Rankine cycle, what I am trying to justify at this point, the picture will be perfectly clear. The Rankine cycle, it closely describes the processes by which the steam operated heat engines, which are commonly found in the thermal power generation plants. So these are some of the basic concepts, basic understandings related to the Rankine cycle. Let us proceed further in some depth in the Rankine cycle. So the next topic for discussion, that is the processes in the Rankine cycle. Dear friends, this image is totally different from the image which is given in your textbook. But for understanding point of view, for clearing the logics, for understanding the technical perspective, I am using this particular image. In the Rankine cycle, there are only four main components. The components of the Rankine cycle includes the turbine, the condenser, the feed pump, as well as the boiler. So these are the four main components of the Rankine cycle. And working of each component describes the process of that particular component. So now let us understand the working of the different components. Let me take a pause from my side and ask you a simple question. Up till now, any doubts from your side related to the Rankine cycle? Up till this point, any doubts from your side related to the Rankine cycle? Okay, fine. So now let us focus on the processes or the working of the Rankine cycle, because if you understand this working perfectly, then I guarantee you that the efficiency derivation will be very easy for you to understand. Starting with the first component, that is the turbine. In the turbine, you are seeing that it is having a special design. There is a gradual increase in the cross-sectional area of the turbine. And in the turbine, we will be having the rotating blades. From the boiler, the steam which is generated, that steam is passed on to the turbine. Generally, we are producing the superheated steam in the boiler, and the superheated steam is passed on to the turbine. Remember friends, just remember that the boiler produces a type of steam, that is superheated steam, which is used in the Rankine cycle. This superheated steam, when it is passed on to the turbine, it will be heating the blades of the turbine, and now the blades will be rotated, the turbine shaft will be rotated, and we will be getting the output work. And the rotation of the turbine shaft will be further transferred to the generator, electric generator, and there we will be producing the electricity. In the turbine, as we are seeing there is a gradual increase in the cross-sectional area. So when the steam is entering into the steam turbines, because of this increase in the area, the steam undergoes the process of isentropic expansion. Remember friends, this is the most important term you need to remember, and also you need to mention in your answer. When the steam is flowing inside the turbine, it undergoes the process that is isentropic expansion. And in the expansion, we are knowing that the pressure reduces and the volume increases. After the steam, okay, so let me ask you once again, is the function of the turbine clear to all the students? Is the function or the working of the turbine clear to all the students? Okay, fine. So now let us proceed further to the second component, that is condenser. In the condenser, what is entering? The condensate steam. The steam, after doing the work in the turbine, now there is no use of the steam to be collected in the turbine, so it is removed from the turbine. So that steam, I am mentioning it as the condensate steam, because the energy of the steam has been removed. Now the steam is not having that much percentage of the energy, or can be considered as the condensate vapor that is passed on to the condenser. In the condenser, we are seeing that through the cooling tower, we are continuously supplying the cooling water. So in the condenser, the condensate steam and the cooling water, they will come in contact with one another. There will be heat interaction between both these components, and now the condensate steam will be now converted into the water. And this water which is generated in the condenser will then be removed from the condenser. And the cooling water from the cooling tower has absorbed the heat from the steam. So that water will be converted into hot water, which is again passed on to the cooling tower, where it is again cooled, and again the cooled water will be transferred to the condenser. So basically the prime function of the condenser is to condense the vapor which is coming out of the turbine. And when it is totally condensed, converted into the water, then and then only it will be rejected out of the condenser. Let me again take a pause and ask all the students whether you have understood the function of the condenser perfectly. Have you understood the concept of condenser? Okay, fine. So again getting the positive responses from the students. Thank you all. So now let us proceed further to the third component, that is the feed pump. Remember friends, the function of the pump is to transfer the liquid from one place to the another place. And pump, for operating the pump, always we need to do the work on the pump. For the operation of the pump, we need to provide the work to the pump. So the water which is coming out of the condenser, that is passed on to this pump. In the pump, the pressure of the water is increased, and this high pressurized water is then passed on to the boiler section. Remember friends, this is the particular design of the pump. This is a type of the centrifugal pump we are using in this cycle. So the advantage of using the centrifugal pump is that it increases the pressure of the liquid. So at the outlet of the pump, I will be getting the high pressurized feed water. And this high pressurized feed water will be passed on to the boiler section. Let me again take a pause and ask you the question. Have you understood the function of the feed pump? I want your comments in the chat box. Have you understood the concept about the feed pump? Okay, fine. Thank you very much. So now let us proceed further to the fourth and the important component, that is boiler. The prime function of the boiler is to convert the water into the steam. And for converting the water, we require the heat energy. So the heat energy to be supplied to the boiler, that is done by the combustion of the fuels. So we are seeing that in the boiler, the fuel air is supplied, and in the boiler, because of the combustion of the fuels, the heat energy will be generated. This heat energy will be transferred to the water. The water, after the saturation temperature of approximately 100 degrees Celsius, it is still heated further, and we are producing the superheated steam. And this superheated steam is then further passed on to the turbine section for producing the work. After the combustion of the fuel, the hot gases which are generated in the boiler, they are passed on to the stack and finally to the atmosphere. So friends, in the boiler, for the combustion of the fuel, we need to supply the heat energy to the boiler. So in the boiler, the energy is supplied. In the condenser, the energy is rejected. In the turbine, the work is produced at the output. In the pump, the work is supplied to the pump. Now let me ask you the final question. Have you understood perfectly the basic concepts of the processes in the Rankine cycle? I want the responses from majority of the students so that I can proceed further with my next topic. Okay, fine. So I am getting the positive responses. Thank you all. So now if you have understood this diagram, then we are proceeding further. This is the ideal PV diagram for the Rankine cycle. This is the curvature showing the PV diagram. This portion, that is this portion, in context of the line, that shows the liquid area, and this portion shows the vapor area. And in the dome of the diagram, there is the mixture of liquid and vapor. So the point number 1, that is with the boiler. So in the boiler, when the feed water is entering in the boiler, at the boiler we are heating the water at the constant pressure conditions, and we are producing the superheated steam. Dear friends, remember in your book, this particular point will be given somewhat outside the diagram. That outside point represents the superheated condition. Are you getting the points? If you are referring your textbook simultaneously, then you will be getting the more concepts, the picture will be more clear to you. Repeating the point once again, this point number 2 is somewhat outside this particular line. And since it is outside in your textbook, we can justify that we have produced the superheated steam. And that superheated steam is then passed on to the steam turbine. In the turbine, I told you that the isentropic expansion process takes place, and in the expansion process, we are aware that pressure reduces but the volume increases. So this 2 to 3 line represents the isentropic expansion of the steam in the turbine. And because of this isentropic expansion, we are able to rotate the shaft of the turbine, and finally we can get the work at the output. So the work is out of the turbine. Now this particular liquid plus vapor type of the steam is then passed on to the condenser, where this mixture comes in contact with the cooling water. This mixture rejects the heat to the cooling water, and finally the mixture is converted to a perfect liquid. Or in simple terms, we can tell that we have developed or created the water in the cycle. So the outlet of the condenser, that will be the water, which is shown by point number 4 in this diagram. Now this particular water is then passed on to the feed pump, the centrifugal type of the pump, where the pressure is increased. So the pressure is suddenly increased in the feed pump. So that is shown by the vertical line, that is 4 to 1, and finally at point number 1 again it is passed on to the boiler, where the water, the unsaturated liquid, first gets converted to the saturated liquid, then it gets converted to the saturated vapor, and still if the heating is proceeded, then it converts into the superheated steam, and then it is passed on to the steam turbine. Dear friends, have you understood the processes on the PV diagram? Kindly share your responses in the chat box. Have you understood? If you remember the logic of it, then it is very easy to understand. And you can present it perfectly during the examination also. And you can score very good marks out of this topic. Let us proceed further and make the derivation of the efficiency of the Rankine cycle. Dear friends, for writing down the equations in the Rankine cycle, we will be using the concept of the enthalpy. All the equations will be writing down in terms of change of enthalpy. And that change we will be considered in simple manner, that is the value having larger enthalpy minus the value having the lower enthalpy. That means the point of higher enthalpy minus the point of the lower enthalpy. I will be using this concept in making the equations. Why I am considering the enthalpy? Because in this particular cycle, the steam is considered as the working fluid. The all four components which we have studied associated with the Rankine cycle are considered as the steady flow devices. In the steady flow processes, there is the mass transfer and the energy transfer across the system boundary, but both these transfers that take place at the steady conditions, at the constant conditions. Hence, they are known as the steady flow processes. And the four devices which are used in this cycle are the steady flow devices. So now let us proceed further with the first component, that is the feed pump. If you understand the figure, then feed pump that is used for process 4 to 1. I am assuming no heat transfer with the surroundings in case of the feed pump. So the energy balance, that is the W pump, because for the feed pump I need to supply the work for the operation of the pump. So I am writing down the equation, that is W pump is equal to H1 minus H4. Remember friends, the point having the higher enthalpy minus the point having the lower enthalpy. At one number, we are getting the high pressurized feed water. So the energy at point number 1 will be higher. At point number 4, we are getting the water at the lower temperatures, which is transferred to the pump. So that we can write down, that is H1 minus H4. Again proceeding further, now let us understand for the turbine. So that is process 2 to 3. And for the turbine, now considering the case of the turbine, the steam from the turbine which has an elevated temperature and pressure expands to the turbine to produce the work, neglecting the heat transfer conditions with the surroundings. The energy balance of the turbine is given as W turbine is equal to H2 minus H3. Because friends, remember the entering point of the turbine, that is the superheated steam having the maximum energy, the highest energy, and the outlet of the turbine, that is the condensate vapor, the energy is lesser. So we are writing down the equation W turbine, that is equal to higher enthalpy minus the lower enthalpy. Have you understood up till this point? Are you getting these equations? If you are correlating the concepts with your textbook, you will be understanding these equations. I want the responses of the students in the chat box so that I can proceed further with the equation for the efficiency. Okay, fine. So now let us proceed further. The third component, that was the boiler. So that is process 1 to 2. The liquid water or the feed water enters the boiler and it is heated to the superheated state in the boiler. So the energy balance of the boiler is given as, any student can now give me the answer for Q for boiler. The amount of heat supplied for the boiler. Any student? What will be the answer of amount of heat supplied to the boiler in terms of enthalpy? Remember, the higher enthalpy minus the lower enthalpy. Okay, so in my case, in my notations, there are some changes in the notations. If you have understood, the process is 1, 2, 3, 4. In my case, the numbers are changed. So I am using the simple terms, that is the larger enthalpy minus the lower enthalpy. At point number 2, I am having the superheated steam. At point number 1, I am having the feed water. So the steam is having more energy than the water. So that is H2 minus H1. Also the answers which you have shared in your chat box, that is also right considering your figures. So now let us proceed further with the condenser. So condenser, that is process 3 to 4. So the steam coming from the turbine is condensed to the liquid water in the condenser. The energy balance in the condenser is now given as the energy rejected, that is Q condenser is equal to H3 minus H4. The point entering the condenser, that is the condensate steam, which is having larger energy, and the outlet of the condenser, that is water. So water will be having lesser energy. So now if we have derived all these 4 equations, then finally I can write down the standard equation for efficiency for Rankine cycle, that is eta Rankine is equal to work done divided by the heat given to the boiler. So that is W upon Q boiler. Now we need to consider the net work done. So work done is equal to work done by the turbine minus the work done given to the pump. So thus eta Rankine is equal to W turbine minus W pump divided by Q boiler. Substituting all these values, I am getting the answer, that is H2 minus H3 minus H1 minus H4 divided by H2 minus H1. But friends, remember, the pump work is very small whenever we are comparing with the turbine work. Hence, that smaller value can be neglected from the equation. Hence, we are neglecting the pump work. So finally, the answer for the Rankine cycle comes out to be efficiency for Rankine cycle, eta Rankine, that is equal to H2 minus H3 divided by H2 minus H1. Dear friends, this is the answer according to my notations, my concepts and my equations. In your textbook, the notations might differ and you might get some different values in the equation. But the concept, the technical approach remains the same. I hope you have understood the efficiency of the Rankine cycle. It is clear to all the students. Okay, fine. Some of the students are replying me in the chat box. Okay, they have understood the concept perfectly. Okay, fine. So now let us proceed further to the last point, though it is not given in your textbook, but for the practical approach in order to understand the practical application of the Rankine cycle. Dear friends, the practical application of the Rankine cycle, that is in the thermal power plants. The thermal power plants are those power plants which are used for producing the electricity. And the main cycle of the thermal power plants, that is the Rankine cycle. And I want to give the example of the thermal power, that in the Ahmedabad near the Sabarmati, we are having the power station of the torrent power. So that is an example of the thermal power plant. And the main components of the thermal power plant, they are the turbine, the condenser, the feed pump, as well as the boiler. And in addition to these four main components, also different supporting components are given in order to increase the efficiency of the cycle. So remember friends, the practical application of the Rankine cycle, that is in the thermal power plants. So friends, with this, I am concluding the session from my side. Thank you for watching this session. See you in the next lecture with the discussion of another important heat engine cycle. Now this session is open for you. If you are having any questions from your side, you can ask me the questions. And remember friends, while preparing the Rankine cycle, if you are stuck at some point, if you are not understanding any of the equation, you are free to ask me. But I suggest that you clear your doubts perfectly so that while preparation for the exams, you prepare it nicely and score good marks in the examination. Any student want to ask me any question related to the topics discussed today, that is in context of the Rankine cycle? Okay, so let me ask you one of the simple question. If you have understood the Rankine cycle, which component is considered as the source in the Rankine cycle? Which component can be considered as the source in the Rankine cycle? Okay, in this case, I am getting the mixed responses. Try to understand. I am asking the which component of the Rankine cycle can be considered as the source. In this, I am getting some of the mixed responses. Okay, I am getting some of the perfect answers from some of the students. So dear friends, remember the overall components of the Rankine cycle: boiler, turbine, condenser and feed pump. If we remember the source, that is at the highest temperature, the maximum temperature. So if we consider the components of the Rankine cycle, then boiler is the source in the Rankine cycle. It is clear to all the students. Boiler is the source in the Rankine cycle. Okay, fine. So with this, I am concluding the session. Thank you all. See you in the next lecture.